Alright guys, I wanted to introduce a little project I've been working on here. This is my fully 3D printed 10th scale RC drag car. I've called this project Sabertooth, just in reference to sort of this toothed or scallop design that you can see on the wings here. But this thing is entirely 3D printed, minus the shafts and some screws and bearings and things like that. Obviously the motor and whatnot. Has a couple unique features that we'll show you here. You know, has front aerodynamics and rear aerodynamics that are, you know, I mean, this is all pretty solid. This car's ran a decent amount on the road. A couple little dings that you can see there from hitting rocks and whatnot, but overall the car's done pretty good. So far for attaching the body, this is a one-piece body. You do need a larger, like 400mm size 3D printer like these over here to be able to print this off in one piece, but single piece body here. Just did some color changes to add some stripes in, but these screws and screw holes here correlate with matching holes on the side of the chassis, so you can screw those right in and it mounts completely flush with the chassis and is completely secure. We'll pop this off, show you the inside. Here's that body, just to show you, just a shell, a thick 100% infill, a 4-5 wall shell here. But yeah, here's the car, and you know, I guess most notably what's interesting about this is the drive package. So this is a solid axle car. That's a belt drive, direct drive, directly from the motor of outrunner motor, like you would typically see on a helicopter or an RC plane. So that was kind of the basis for this project here. I just wanted to see what was possible with these motors. In theory, they should have more torque than what a conventional inboard motor would have, and it seems pretty promising so far with what I've done with this car. So this is a 36/48 size brushless outrunner motor that you can get on Amazon for about $20. About 900 watts, so it puts it in par with like a mid kV, you know, normal, you know, like 540 size brushless motor. So equivalent in power to that, but in theory it should have more torque. This one is 1100 kV. We're running this on 4S. This is a 1300 milliamp high output 4S pack for drones. Just basic receiver, some leftover parts here for the receiver, and servo there. Using a hobby wing quick run 120 brushless ESC here. These things are great. I've ran them in multiple projects. They're waterproof. They can take a ton of abuse. They have a lot of programming options, so those are really nice. So we'll do a little preview here. I mean, this little guy really has some power. We're gonna have to hold on to it. So she she really goes, and I'm showing this off because I think I finally have the drive line figured out for this car. It was a struggle, and mainly, you know, and these are fully 3D printed pulleys. These are ABS. We started out with PLA, but just for the durability, something a little tougher with this ABS here. But it was really difficult to get these to affix to the shaft. What we ran at first was a configuration like this. Well, first we didn't have the inserts there. We tried just screws straight onto the shaft. Those would come out immediately. These did okay, so we sized the holes here for some press-in 3M inserts. Those would go onto the shaft and clamp on from two directions onto a flat spot on the shaft here. That would work okay. You might get a decent run or two out of it, but this would always slip, come loose, start to crack along here, start to pull out the insert. So that didn't work very well, so I wanted to find a different solution here, and I'll show you what I found. We'll take a look here at the wheels, because we actually utilized this same part here to attach the wheels. So you can get these on Amazon, a 4-pack of them for a few dollars. And it's a 12mm hex adapter that's made out of, I believe, brass. Comes with 2 set screws, also a hole on the end, which is really handy. It's an M4 hole. So we just took our shaft, which the shaft here is titanium. We just ground a flat spot here right in line with where the set screw would be, and this is as solid can be. I mean, this is not going to go. So yeah, that's how we do the wheels on the back there for the attachment. These are really handy. You know, these particular ones are an 8mm to match the 8mm titanium shaft here. And just attach on there, super solid. So yeah, we took inspiration from that, and we got these with a 5mm hole instead of an 8mm hole, which matches our shaft diameter here. We also did this in the rear. Then we took our 8mm and we actually bored out the front of this so it would slip all the way along the shaft to here, where we have a flat spot on our shaft, securing this midway along the shaft. And then we revised our pulley from this set screw style to this new style. It's a tight fit, but this will fit in here and slips along here, and then is held in place because it bottoms out in this direction, and it's secured in this direction by a little thrust washer that is in here alongside the bearing in these pillow block bearing housings in the back. So with this new driveline, I mean, this thing is rock solid. I have a handful of 10th scale belt drive cars, Serpents, Dragnalos, a variety of different stuff. And I feel this is just as sturdy as what those are. So that was the big innovation with those here. So we have our titanium shaft, these which slip on the end, our wheels go onto. Right now these are just held on with small 4mm screws. That doesn't work out too well. You really got to Loctite those on. So what we're going to move to is a 4mm stud or set screw that will be screwed into here and then permanently glued into place. This will go over the hex and the stud, and then a 4mm nut will hold those on. That'll work a lot better than the screw coming loose. And then we just have a little 8mm collar here. There's also a flat underneath that's held right in place, keeps the axle perfectly solid. There's no side-to-side play whatsoever. And then there's just a little thrust washer in there alongside the bearing that's in there. And I made an error. The thrust washer that is on this side is not up against the bearing. It's up against the housing of the bearing block there. So just to talk about these bearing blocks a little bit here, these are, you know, obviously fully 3D printed, 100% infill. You can't see them from this side, but here's one of the screws. There's another here and another here, but there are little slots on the side of these here and here that M3 screws slide into. And then your screws come in from the bottom. They pull into those screws, which are embedded inside of this part, and it just locks it in there as solid could be. There's a little rail along the back here that these bearing blocks fit into, help keep everything aligned, and it gives you some adjustability in your tension. Really, we're about fully tensioned out with these in the fully retracted position, so there's really a lot of room there. Really can't, at least with this motor configuration, go too much bigger of a pulley here, but if you did, you could go with a bigger pulley in the front here and a longer belt and be able to move everything back. But yeah, so we'll take a look at the wheelie bar system back here. Nice little touch on this. Again, this is fully 3D printed minus the little links here. But our wheelie bar wheel in the back here, funny enough, is actually a wheel from a 3D printer, you know, to go with the 3D printed dragster here. But it's a wheel that aligns one of the axes on your 3D printer there. It's a very tough material, 2 good quality bearings in there, so that works really well. This piece all attaches onto the back, and then actually a 3D printed turnbuckle here, and this works out great because it's large enough that you can just adjust it by hand. We have heat threaded inserts pushed into there, and this can tension this and allows you to move your wheelie bar up and down. Car like this, solid axle, you know, we'd run the wheelie bar pretty close to the ground. This car obviously is going to require a very smooth track, but so just to look at the rear sort of downforce here, this is all one piece, here, here, through here, up here, down here, all one piece. You can see this side has some supports on it. It's not quite as nice as this side, but works great. And our attachment method here for our wing slides over there, and we have a nut and screw holding that down. It's very, very sturdy. The whole car really is. So I also have files to be able to print this car into 2 pieces. If you don't have a large 3D printer, you have a normal size 3D printer, you can actually print this whole car in 2 pieces, and it sort of clamps together in here, and it is still very, very solid. I recommend probably printing that one 100% infill. I tried doing this in 100% infill. It was too heavy, and it was actually too rigid. The car, see how it has just a little bit of flex here. The back motor section is reinforced so you don't get any flex in here, loosening the belt, but there's just enough flex here. If you do print it in 2 pieces, there's some holes here. You can put some M2.5 screws in there, and then use like a hair tie and be able to hold your battery in. You can't really get a screw in there with the one-piece chassis, so I'm just using Velcro here, but that works just fine. So the motor mount, this is really kind of interesting. Obviously fully 3D printed, mounts in the back here for your outrunner motor to be able to spin freely, cut out for the bearing to be able to spin in there. And this whole motor mount is actually 2 pieces, so from here over to here is 1 piece. This pulley, because you can't normally run this sort of a motor as a belt drive. Really, most brushless motors or electric motors you shouldn't, because the amount of tension needed to put onto this belt to keep it from slipping will deflect that shaft and put a whole lot of load, what would that be, maybe axial load against the bearings in here, and really wear it out. So what we have here is along the end of this pulley there's a stub shaft that sticks out and rides inside of a bearing and inside of a hole right in here. So because of that, this whole assembly actually takes the tension of the belt without pulling and trying to deflect on that motor shaft. So you can run as much tension as you want on this belt, and it's still going to spin very freely, and it's not going to want to pull that motor in the direction of the belt tension. So that was a big innovation with this. We'll take a look at the front steering system here. We did have to borrow a few parts from normal conventional RC cars here with the links and the servo horn and whatnot. This is a solid, it is a rigid front suspension, but what I've done here is you can actually control the thickness and the walls and infill of these upper and lower control arms to change the characteristics of what is essentially your suspension. So this is one part of this build I'm still working on, is sort of the attachment system for these front wheels. So what we have here is a conventional bearing block. It turns along here. There's threaded inserts top and bottom that keep everything very, very solid. 3D printed 12mm stub shaft that fits all the way through with an inner and an outer bearing. A little bearing protector cap there, and sort of a tensioner assembly to keep this smooth but also very rigid. and that's worked very well. So, you know, on this side, this is just a set screw with you know, the anchor nut on it, and this will hold this right on here. I think eventually I might go to a single long set screw that completely goes through the entire assembly, but I wasn't able to find one that was quite long enough. It was like a little over 30 millimeters the length, and I couldn't quite find that. But yeah, you can see there's sort of a middle bearing block here that suspends the top and bottom, but there is you know, a decent amount. There's enough suspension movement. I mean, this car is very, very smooth, even over mildly, what I would call mildly smooth concrete. Not the best, definitely not something you would want to run a car like this on. You know, and speaking of that, the way we have this set up right now is with these wide BSR drag tires. These are like 45 millimeter wide, 38 short, you know, tires. These are great for drag racing, especially if you want to use some prep or not. This car is probably going to be better for drag racing with the current gearing setup and battery setup. You're going to top out at around 85 miles an hour or so with this car. I do have plans. This is the next phase for this car here. We're going to use a conventional inboard 3660 size motor here. This is a very high kV, 4700 kV motor that's designed to fit right in place of this one. We're going to revise this one, add some supports underneath there to take the load of this motor. But with this setup here, you can remove this and use any Mod 1 gear with an 8mm shaft. It'll slide right on there. You can use your grub screw right on the flat spot and just have a gear right here. You'd be limited to around 30 or so teeth on a Mod 1. That's about the size of 30-tooth Mod 1. And I would have to move this mount back a little bit to allow everything to mesh up. But so we're going to keep working on that. But for now, we're pretty happy with the belt drive car. We'll take these off. This thing really screams. And extremely solid, this ABS pulley system here that's engaged directly onto a titanium shaft with these metal collars here. So very happy with this project. We're gonna get some video of it running, doing some speed runs, doing some drag runs with some prep. But yeah, there it is, Project Sabertooth, little 3D printed 10th scale dragster there. Come get you some.